Hi, Assalamualaikum. Welcome to the presentation video about our assignment. The big title for this assignment is Application of Differentiation and more specifically is Related Rates. Our group name is Team ORI. We consist of 5 members. Firstly, Muhammad Sarfan bin Bahrudin with his metric number 2020469728. Secondly, Muhammad Iman bin Zainuddin 2020473246. Thirdly, Amirul Ikhwan Shah bin Muhammad 2020620192. Then Nur Syafiq Najmuddin bin Zainuddin 2020842398. Lastly, Muhammad Luqman Hakim bin Muhammad Azwan 2020451696. And all of us from RCS 1432C group.
Firstly, what is differentiation? Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. Informally, we may suppose that we are tracking the position of a car on a two-lane road with no passing lanes. Assuming the car never pulls off the road, we can abstractly study the car's position by assigning it a variable x. Since the car's position changed as time changed, we say that x is dependent on time, or x equal to f of t. This tells where the car is at each specific time. Differentiation gives us a function dx over dt which represents the car's speed. That is the rate of change of its position with respect to time. Why we use differentiation? Differentiation allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve.
Next, here are some problem statements that need the use of differentiation method to solving it. Water is being drained out of a cylindrical tank with a radius of 12 in. The height of the remaining liquid in the tank decreases by 3 in per minute. So, the question is, how quick is the water being drained?
For the solution of problem statement that was informed by Iman just now, what we can deduce from the statement is that we need to find the rate of water being drained out of cylindrical tank. So, the volume of the cylindrical tank, which is V equal to pi r square h, should be differentiated into dV dt. From the information we have obtained, it has been stated about rate of height declining by 3 inches per minute and radius equals to 12 inches constantly. Before that, in the formula, we need to put -3 for dh dt. This is because the rate height is declining, which means decreasing. This means that mathematical sentence would be dV dt equal to d dt pi r square h. Cos of r and pi is constant, so it could be simplified into dV dt equals to pi r square times dh dt. Then, if we plug those things into the formula, it will be look like this. dV dt equals to pi times 12 inches times 3 inches per minute. The answer should be -432 pi inches cubed per minute.
So, there are several steps that will make it easier for us to solve the problem. One of that is, we need to identify the shape of the prism involved and use the information given, such as height and radius. Then, we need to know what is the desire in question and we can solve it smoothly. For example, like the problem statement above, we were able to solve that the water volume of cylindrical tank is being drained at the rate of 432 pi inches cubed per minute.
That's all from us. Thank you. See you again. Bye.